In the previous lecture, we have discussed how to expand a given binomial expression. So for x plus a raised to the power of n, the expansion would look something like as shown on the board here. So here, the first term, let's write it down. The first term is nc0 x raised to the power of n, a raised to the power of 0. The second term is nc1 x raised to the power of n minus 1, a raised to the power of 1. Our third term is nc2 x raised to the power of n minus 2, a sub squared, and so forth. So here we observe that the suffix of c, if we consider any term, the suffix of c for the first term is 0, for the second term it's 1, for the third term it's 3. It's always 1 less than the number of terms. What I mean to say, if the number of terms, if you're talking about the first term, then the suffix of c is 0. If you're talking about the second term, the suffix is 1 less. So there is 1 here, so third term. So similarly, if we talk about the fourth term, then it will be nc3. So this tells us that the r plus 1th term. So if we are to talk about the r plus 1th term, then that particular term will look like nc, it has to be 1 less, so it's going to be ncr x raised to the power of n minus r times a raised to the power of r. So this particular term is known as the rth term. So this is the rth term, also known as the r plus 1th term. So this is the r plus 1th term. This is the r plus 1th term, and this is referred to as the general term of the given binomial expression. General term. So, using this, let's try to find out one general term of a question. So let's say we are provided with an expression x squared minus y all raised to the power of 6, and we have to find out the general term of this binomial expression. Okay, so what we can do, we'll do a little bit of algebraic manipulation. The first term will remain x squared, then we plus a negative y. Yeah, this first term will be a, the second term will be b. So the general term, which is the r plus 1th term, is going to be equals to ncr. So here n is equals to 6. So we'll have it is as 6cr, so 6cr, then a raised to the power of 6 minus r. So a here is x squared raised to the power of 6 minus r times negative y, which is b, raised to the power of y. Then we simplify, so x squared raised to the power of 6 minus r, now the powers will get multiplied, so we'll get 12 minus of 2r, then y raised to the power of r. Y, negative y can be also written as negative 1 raised to the power of r. So we have pulled out negative 1. So this is how the general term of x squared minus 1 raised to the power of 6 looks like. So what's the use of this thing? So if with the use of this general term, we can find out any given term. So let's do it with the help of an example. What I mean to say, let's say I have a binomial expression twice x squared plus x raised to the power of 12. Here, let's say we are asked to find out the 10th term. Now, instead of writing each and every terms and then figuring out what's the 10th term, it's going to take us a lot of time. So what we're going to do is we're going to use the concept of the general term and then figure out what's the 10th term going to look like. So since we're talking about the 10th term, so T10. So instead of writing T10, so we write it as T 9 plus 1, so such that this will represent our R. This will be equals to 12 because the value of index n is 12. So we have 12c 9. Now we take the first expression, the first term, which is twice x squared raised to the power of 12 minus 9 times the second term, which is 1 upon x, all raised to the power of 9. That's it. So this is the 10th term. Now all we have to do is find out the value of 12c9. So the 12c9, you can use a calculator. Let me quickly find it out. 12 factorial divided by 9 factorial times 3 factorial. So this will be 12, 11, 10, 9 factorial, and 9 factorial gets cancelled out. So we have 3, 2, 1. 3 times 2 is 6. 6 times 2 is 12. So 2 times 12 is 22. So this is going to be 220. So 220. And we have 2x squared raised to the power of 3 and 1 over x raised to the power of 9. So this is equals to 220 times 2 raised to the power 3 is 8. X raised to the power, x squared raised to the power of 3 is x raised to the power of 6 divided by x raised to the power of 9. And we multiply 220 and 8 to get 8 times 2 is 16, 1 for 8 times 2 is 16, 1760. And x, this will reduce to x cubed. So x cubed factors out x raised to the power of 6, factors out x raised to the power of 6 in the denominator, and we're left with x cubed in the denominator. So this is the 10th term in the binomial expansion of twice x squared plus 1 over twice x squared plus 1 over x raised to the power of 12. So this is the 10th term. So here we can find out any term. So using the formal concept of the general term. So in this question, we have to find out the 9th term in the expansion of this binomial expression. So let's do that. So we have to find out the 9th term. So t of 9 can be also written as t of e plus 1, so that this becomes the value of r. So this is equals to 12c8. So we take the first term, which is x over 8 raised to the power of 12 minus 8, which is 4. Then we take the second term, we have to take the negative as well, negative 3a over x squared raised to the power of 8. So this is the 9th term. So we do some simplification. So this will give us x raised to the power of 4 divided by a raised to the power of 4 times negative 1 raised to the power of 8. Also, let's write it down, negative 1 raised to the power of 8. And we have 3 raised to the power of 8 times a raised to the power of 8 divided by x squared raised to the power of 8. So the power indexes get multiplied to give us 16. Now what we do, we can factor out all the common terms. So x fourth and the 16 will cancel out to leave us with 12. A raised to the power 4 in the denominator will cancel out 4 terms in the denominator, leaving us with a raised to the power of 4. Okay, there we have 12c8. Oops. We have 12c8. So negative 1 raised to the power this 8 is 1. And we have 3 raised to the power of 8 times a raised to the power of 4 divided by x raised to the power of 12. So you can go ahead and find the value of 12c8 and 3 raised to the power of 8. That's going to be a very huge value. I'm skipping it here. So this is our 9th term in the expansion. Let's go to the next question. So in this question, we have to find out the 6th term and the expansion of the given binomial expression. So we take t6, which will be equals to t 5 plus 1, so that this 5 becomes the r value. Then we have n equals to 9, so we have 9c5. The first term is 4x divided by 5 raised to the power of 9 minus 5, which is simply 4, times the negative of 5 over 2x, all raised to the power of 5. So we have 9c5 times 4 raised to the power of 4 times x raised to the power of 4 divided by 5 raised to the power of 4 times negative 1 raised to the power of 5 times 5 raised to the power of 5 divided by 2 raised to the power of 5 times x raised to the power of 5. So we'll finally have 9c5. Now here we see that 4 raised to the power of 4, the 4 raised to the power of 4 is actually 2 squared raised to the power of 4, which gives us 2 raised to the power of 8. So we have 2 raised to the power of 8 in the numerator, and then we have 2 raised to the power of 5 in the denominator. So since it's in the denominator, when it goes to the numerator, we simply subtract the indices. So it will be simply 2 raised to the power of 8 minus 5. Then negative 1 raised to the power of negative 5 is simply going to be negative 1. Then we have 5 raised to the power of 5 in the numerator and 4 in the denominator. So they will simplify to give us 5 raised to the power of 5 minus 4. Then we have x raised to the power of 4 minus 5. So the final value will be negative. I pulled out the negative 1 to the front, so it will be simply negative 9c5, 2 raised to the power of 3, and 5 times 5 times x raised to the power of minus 1. So this is going to be the sixth term. So in this question, we have to find out the 13th term. So we have t13 equals to t 12 plus 1, which is equals to 18c12. The first term is 9x raised to the power of 18 minus 12, which is 6, times negative 1 over 3 times the square root of x, all raised to the power of 12. This is equals to 18c12. So 9 raised to the power of 6. So 9 raised to the power of 6 is equals to, so 9 is 3 squared raised to the power of 6. So this is simply 2 times 6 is 12. So we get 3 raised to the power of 12 times x raised to the power of 6. And we have negative 1 raised to the power of 12. Whole thing divided by 3 raised to the power of 12 times square root of x can be written as x raised to the power of half, and the whole thing is raised to the power of 12, which gives us 18c12. So the 3 raised to the power of 12 in the numerator and the denominator factors out. Then we have negative 1 raised to x raised to the power of 6, and this one x raised to the power of half raised to the power of 12 is simply x raised to the power of 12 divided by 2, which is 6. So does it mean that the x raised to the power 6 in the numerator cancels out the similar term in the denominator? So we're only left with negative 1 raised to the power of 12, which is always positive. So the value of 18c12 18c12 will be equals to, let's use the calculator, 18c12 is simply 18,564. So that's the value. Let's move on to the next one. So we're given a binomial expression, and here we have to find out the seventh term. So let's do it. So we have t6 plus 1. I'm typing straight away this time. So t6 plus 1 is going to be 10c6, and we have 3x squared raised to the power of 10 minus 6, which is 4, times negative 1 over x cubed raised to the power of 6. So this is equals to 10c6, 3 raised to the power of 4 times x squared raised to the power of 4. So 2 times 4 is 8, times negative 1 raised to the power of 6. And the whole thing is divided by x raised to the power of 3 times 6 is 18. It's 18, which is equals to 10c6. 3 raised to the power 4 is 81, times negative 1 raised to the power 6 is always positive 1. And we can bring that x raised to the power 8 to the denominator, so that we'll get 18 minus 8. And we find out the value of 10 raised to the power 10c6, which is 10c6. So that is 210. 210 times 81, whole thing divided by x raised to the power of 10. So the final answer is 210 times 81 is 17,010 divided by x raised to the power of 10. So this is the seventh term in the expansion of 3x squared minus x 1 over x cubed all raised to the power of 10. So we have this binomial expression. We have to find out the eighth term. So eighth term will be simply t7 plus 1, which is equals to 10c7. The first term is x raised to the power of 3 over 2 times y raised to the power of half whole raised to the power of 10 minus 3, which is simply 10 minus 7, which is 3, times the negative x raised to the power of half times y raised to the power of 3 by 2 whole raised to the power of 7. So 10c7, let's find out. 10c7 is 120 times x raised to the power of 3 over 2 times 3, which is simply 9 over 2, times y raised to the power of 3 over 2. Then we have negative 1 raised to the power of 7 times x raised to the power of 7 times half is 7 over 2 times y raised to the power of 3 times 7 is 21 over 2. So we have negative 1 raised to the power of 7 is negative 1. So that gets multiplied by 120 to give us negative 120. X raised to the power, so x raised to the power 9 over 2 gets multiplied to x raised to the power of 7 over 2 in such a way that the powers get added up. So we have 9 plus 2, 9 over 2 plus 7 over 2 times y raised to the power of 3 over 2 plus 21 over 2, which is equals to negative 120 x raised to the power. So 9 over 2 plus 7 over 2, when you add them up, you get 9 plus 7 is 16 over 2, so that gives us x raised to the power of 8. And y, we have 3 over 2 plus 21 over 2, that gives us 24 over 2, so which is finally 12. So this is the 8th term. So in this question, we have to find out the 7th term in the expansion of the given binomial expression. So the 7th term will be simply t7 is equals to t6 plus 1, which is equals to 8c6. And the first term as 4x over 5 raised to the power of 8 minus 6, which is square, times 5 over 2x raised to the power of 6. Now 8 says 6, 8 says 6, let's find out the value. 8 say 6, it's 28. So 28 times 4 squared x squared over 5 squared times 5 raised to the power of 6 divided by 2 raised to the power of 6 times x raised to the power of 6. Now 4 squared can also be written as 2 squared whole squared, which is simply equals to 2 raised to the power of 4. So we have 28, or you can simply use a calculator to find out the value of this particular constant, or you can say the coefficient. 2 raised to the power, let's write them together, and we are left with x squared over x raised to the power of 6. This is simply going to be x raised to the power of 6 minus 2. So we can use the calculator, and the constant value will be 4375 divided by x raised to the power of 4. So this is the answer. So in this question we have to find out the value of a such that the 17th and the 18th terms in the expansion of 2 plus a raised to the power of 50 are equal. So let's begin by finding out the 17th term. So T17 will be equals to 50C16, and we have 2 raised to the power of 50 minus 16, which is 34, times a raised to the power of 16, and the 18th term will be equals to 50C17 to raised to the power of 33 times a raised to the power of 17. So it's given that T17, the 17th term, is equals to the 18th term. So let's equate them. So we have 50C16 times 2 raised to the power of 34 times a raised to the power of 16 equals to 50C17 times 2 raised to the power of 33 times a raised to the power of 17. Now 50C16 can be written as 50 factorial over 16 factorial times 34 factorial times 2 raised to the power of 34 times a raised to the power of 16, which is equals to 50 factorial times divided by 17 factorial times 33 factorial times 2 raised to the power of 33 times a raised to the power of 17. Now what we can do, we can factor out the common terms from each side. The 50 factorial will cancel out 50 factorial. So we have 2 raised to the power of 34 here and 2 raised to the power of 33. So this will factor out 2 raised to the power 34, 33 terms, so leaving us with only a single term. Similarly, a raised to the power 16 will factor out a raised to the power 16 on the right hand side, leaving us with only a single a. Then, okay, let's write down the simplified values. So we have 2 remaining divided by 16 factorial times 34 factorial equals to a divided by 17 factorial times 33 factorial. Now, what we can do is we'll do a few more adjustments here. So we have a 16 factorial here. So 34 factorial can be written as 34 times 33 factorial. While on the right hand side, we can write 17 factorial as 17 times 16 factorial times 33 factorial. Now we can factor out 16 factorial from both sides and 33 factorial as well. So this will finally leave us with 2 over 34 equals to a over 17, which is finally 2 times 1, 2 times 17, and then 17 and 17 will factor out, leaving us with a equals to 1. So that is the value of I.